Hi, I'm Paul Miller, Vice President of Product Strategy at Wind River. In this presentation, I'm going to talk about a piece of technology that, if done right, will enable a new world of connectivity with opportunities we have only begun to imagine. We'll be taking a look at 5G, its motivations and potential, and the exciting intersection of this with virtualized edge computing. We'll show how a well-executed distributed edge cloud sets the cornerstone for a successful 5G network. It is that foundation that will enable fast 5G deployments at scale with lower operating expense. Today I'll discuss how Wind River makes this possible. Let's start with a quick introduction to Wind River. Wind River has been in business for nearly 40 years, and during that time has been the market leader in embedded software. In telecom, Wind River has been trusted for decades by all the leading equipment manufacturers that equip deployments in the carrier space, including powering the majority of 4G and 5G deployments to date. As compared with other infrastructure software companies that primarily focus on enterprise and IT use cases, Wind River is unique in building software to the highest standards as required for safety-critical systems in avionics and automotive applications, ultra-high security solutions, defense systems, and high availability and scalability for next-generation cloud infrastructure for telecom networks. As we move into the 5G era, these capabilities and this experience is ever more relevant. 5G has taken the market by storm, and for good reason. It represents enormous opportunity for service providers and the businesses and people they serve. The presence of significant technological innovations, coupled with new use cases that legacy technology cannot meet, has driven this to the forefront. The ability to support advanced applications that our culture has come to expect, such as augmented reality and virtual reality, autonomous self-driving vehicles, and remote healthcare services is only possible with 5G and its increased throughput and low latency. At the same time as our culture anticipates and demands this transformation in our technology experience, generational change has been transforming the virtualization landscape. Through virtualization, it is now possible to deploy and operate highly distributed edge cloud technology and operate it as simply as a single centralized cloud used to be. Thus, we have the convergence of two paradigms, the emergence of 5G and a major technology shift in virtualization that are made for each other. We see the transformation of the service provider network into one run fully virtualized, distributed, and at lower cost than ever before. This transformation then enables new revenue streams from the use cases we've just covered, but within a more flexible, faster, and lower-cost cloud infrastructure. However, we now see ultra-low latency introduced as an obvious key requirement to support the use cases around the new revenue streams that we've just discussed. Further, the virtualization technology must now be operated in a geo-distributed topology, with compute infrastructure distributed across tens of thousands of physical sites, as the overall end-to-end network becomes fully virtualized all the way to the far edge. Once the capability to meet these base technology requirements has been proven, we now transition to the more operational aspects. Obviously, with a geo-distributed virtualized cloud at tens of thousands of sites, the ability to do this with low effort has a more than significant impact on a service provider's expenses. Therefore, high levels of automation, such as administration from a single pane of glass, ensuring that the deployable software is fully pre-integrated out of the box, and introducing automation for remote site deployment fully hands-off as a zero-touch deployment model are required. These capabilities are key to lowering the service provider's operational cost in deployment of a massive network. When we look at the day two aspects, once the network is deployed, a completely new set of considerations surface. A live network bound by 5.9's performance requirements can no longer be taken out of service for upgrades and updates. This must be a live capability for hitless software update. Finally, ensuring visibility onto the ongoing distributed network via big data analytics provides the ability to aggregate and view live network logs, alarms, and key performance data to a centralized dashboard with visualizations, reporting, and advanced ML and AI capabilities that can enable predictive analytics. So, we know 5G has huge potential, and we know it comes with unique and challenging requirements. Successful deployment of a distributed edge cloud really is the cornerstone of success. The question is, how does Wind River make it possible? The answer is Starling X, the first fully distributed edge compute cloud solution based on cloud-native Kubernetes first principles. This is an open-source community project initially founded by Wind River and Intel and hosted by the OpenStack Foundation, designed around a CNCF-certified Kubernetes distribution. More importantly, though, it has the unique StarlingX project enablers that transition this modern but enterprise-centric container technology to one that is hardened, production-grade, 5 nines, and is fundamentally enabled to be geo-distributed across thousands of sites. This is the next-generation technology that meets and exceeds the core 5G cloud-native requirements and enables low cost for day 1 and day 2 critical operations. Designed with high-scale service providers in mind, this open-source technology far exceeds any other cloud solution in the market today. StarlingX then represents the ideal open community, open-source environment in which to drive the best possible crowdsourced innovation into edge compute technology. As we'll see, this technology combines many open-source initiatives such as Kubernetes, container runtimes, cloud-native SDN controllers, OpenStack, and big data components into an integrated whole. Wind River then takes the responsibility to deliver a production-grade hardened version of this software to market, provided as our product Wind River Cloud Platform. In this manner, the service provider can receive the best of both worlds, an open-source project that they can influence and benefit from community innovation while deploying a hardened, production-grade version into their networks. It is also important to invest across the spectrum of community and open-source activities. This ensures that the product direction and open-source contributions that we make are aligned to the service provider needs. For example, in vRAN, Wind River is deeply involved in Workgroup 6 and the vRAN software community INF team, including the contribution of StarlingX and Yocto Linux to that initiative. This is a key activity driving the future of 5G vRAN technology, well worth our investment in time, people, and software. This goes on and on across Acrano, the Telecom Infra Project, Etsy, and Open Source Mano. In every case, not simply a logo on a slide, but a serious activity with real investment in people and expertise. All this activity and investment has resulted in this high-level software architecture. First, notice that the foundation of this architecture is a cloud-native first, Kubernetes and container runtime on bare metal approach. No toolset or software infrastructure components exist to transform Kubernetes to a multi-site, geo-distributed, and edge cloud architecture. This is the reason StarlingX has emerged as an open-source project, to provide the software functions that enable Kubernetes-based cloud-native infrastructure to extend across thousands of sites and to do so with a simple operational model enabled by high levels of software automation. The distributed edge cloud component enables a multi-site, true distributed control plane that supports deployment and operation of Kubernetes as a fully distributed cloud solution. This includes single pane of glass support to view and operate the infrastructure from a single high availability control point. This provides aggregated views of fault management, enabling the operator to see all system alarms, synchronization status, and fault information from that single dashboard. This also provides an ability to apply live in-service updates and upgrades to the deployed cloud infrastructure. Finally, infrastructure orchestration provides the ability to perform full zero-touch for deployment and provisioning, enabling turn-up of these thousands of sites as a fully automated function. This is critical to operational concerns around effort and cost. Therefore, you can see the fundamental difference with Wind River Cloud Platform. This is a solution that uses the latest cloud-native technologies, but then also provides real production-grade, high availability, and operationally low-cost suite of capabilities that enable this to be deployed and operated as a geo-distributed cloud infrastructure. Now, as we return to a 5G perspective, you can see the applicability of these functions in the 5G vRAN use case. The vRAN architecture for 5G is fundamentally a virtualized approach, using generic compute infrastructure at each site in the operator's network to host various functions that create the 5G capability for the service provider. Applying Wind River Cloud Platform to the requirements, you can see a few attractive things emerge. First, a 5G network typically covers a very large physical footprint. Therefore, applying generic compute and virtualization across this footprint represents a geo-distributed architecture. To avoid the high operational cost associated with managing such a diverse deployment, typically over tens of thousands of sites, The Wind River Cloud Platform enters as the infrastructure of choice that can manage the entire virtualization deployment as a single entity. Finally, at each site as the network evolves, it is key to be able to expand each site, often with different hardware as technology evolves in the hardware market, to support growth in the required compute capacity at each site for applications such as MEC. Drilling down into the scalability, we see that Starling X provides some unique capabilities that are very useful for 5G deployment. Legacy technology has now evolved to the point where operating the large-scale national data center at the far right is quite commonplace. However, the ability to simultaneously scale all the way down to a single node at a remote site, what we call an all-in-one or hyper-converged node, and to do so in an efficient manner that doesn't impact that remote node's ability to support data-intensive workloads is very important. Starling X and Wind River Cloud Platform provide this ability to manage across all the sites as a distributed cloud, but also provides the ability to scale down to a hyper-converged node where it still operates as a fully autonomous cloud, including Kubernetes master functionality and Starling X remote management functions. As you can imagine, an operator deploying tens of thousands of sites would consider the hardware impact of a single node versus a multi-node requirement at that site as something that dramatically impacts the CapEx component of a 5G business case. Likewise, from an operational standpoint, the ability, as we have discussed, to operate the entire cloud end-to-end from a single pane of glass is very important to driving down the effort to manage the geo-distributed infrastructure. A single pane of glass needs to provide the ability to have a view across the deployment, including aggregation of fault and alarm status, visibility into subcomponent operations, performing software upgrade, and the ability to tunnel down into remote subclouds and manage them independently. A well-thought-out approach such as this provides a key operational enabler to significantly reduce the effort a service provider must expend to deploy and operate such a network. Of course, this infrastructure we've been discussing is part of a classical disaggregation approach, which has moved our industry from a monolithic proprietary system to a multi-vendor environment. In this new paradigm, these multiple vendors' components are integrated into the solution that becomes the new 5G network. Our platform and like is dependent upon and runs on the hardware infrastructure. We've seen an emergence of various solutions here with attractive abilities to support requirements from the highly scaled core deployments with classical data center high scale, all the way through to new far-edge platforms that are more secure, cost-efficient, and optimized for that single node type deployment. Through this transformation, it is important not to lose sight of this disaggregated paradigm, as vendors that work best and cooperate together will drive ease of adoption for the service providers consuming this technology. So to wrap up, as you can see, Wind River is investing heavily in the 5G vRAN infrastructure space. Our Starling X-based Wind River Cloud Platform offers industry-unique and critical capabilities that provide a technically superior solution for 5G needs. These couple with the operational benefits that are so important to the operator to enable the production-grade deployment of a geo-distributed network with thousands of nodes. Delivering this solution, enabled by our approach in open source and open community activities, ensures we have a deep telecom expertise in 5G and cloud-centric concerns for service providers. Of course, no vendor providing solutions to the service provider market can be without a direct carrier-grade support and professional services capability, and we are no different. So, here at Wind River, we're excited about our production-ready foundation for 5G and the traction we have worldwide with key service providers leveraging this technology. Clearly, the case has been made for virtualization as the foundation for high-scale edge compute, and with the right technology, this has moved from fiction into reality. Thanks very much for your time in watching this video.